Okay, members, today we are going to see a point dividing a line segment internally and also a point that is dividing a line segment externally. Now, remember we are still this one is a part of ratio theorem. Now, the internal and external division, consider point P dividing the line segment AB. Now, if it's internally, this AB, this P will be inside AB as you see. So if I divide this line segment into 3 sections, this is 1, this is 2, this is 3. So it's like this will be 1, 2, 3. Now, if I remember direction or is the line segment AB, so we take this direction like this. Be careful the direction, the vectors they are very close. Now, it means that now, if I want to get the ratio of AB, I mean AP to PB, it will be, now the ratio of AP is that on these 3 lines, I mean on these 3 segments, AP is taking 1, 2, PB is taking the last 2. So AP to PB is equal to 1 to 2 in that order. So don't forget the ratio theorem also. Now, when I come to external now it means that this point that is dividing is outside the line or is beyond that line. So it's like if this is my line AB, this point can be this side or it can be this side. All this, if this side is external, if it's this side is also external division. Now, if I want the same ratio of AP to PB, look at this very carefully. If I want AP, it's like I already have the AP, but you see that AP I'm moving in this direction. So I'm now changing the direction of the line AB. That's why AP, still this one is divided into 3. This is 1, this is 2, and this is 3. So it's like AP is taking one segment, but in the negative direction because it's opposite to the direction of AB. That's why I'm having the negative here. 2, now PB, so that PB is in the same direction, PB, that's why this is positive. So, alright, if we have external division, one of the ratios is negative. You can even, this can be negative. Now, alternatively, if I consider now, you look at this. If I say now the ratio of PA, if I consider the ratio of PA, you see PA now to BP. BP. So it's that I would have changed the direction. So PA is in the direction of AB, so it's positive. To BP, it's that the BP is opposing, but BP is taking 1, 2, 3, which is negative 3. So you see, if it's a third division, one of the ratios should be negative. You should put that in mind. So if they give you, when all of them are positive and they say internally, you consider the signs of the ratios. But if they say externally, one of the ratios should be negative. So if all the ratios are positive, you just attach a negative to any of the ratios. Hope I'm clear. If it's already negative and one is positive, that one is okay. But if they are positives, one should be negative. Negative. Now, look at this. Find the coordinates of a point P which divides the line segment joining points A and B in the ratios of 2 to 3 internally. Now internally we just use the ratio theorem direct. So we assume we have a point number 1 internally. Internally, we assume we have a point A, then a point B. This P now is internally in the ratio of 2 to 3. We said in our ratio theorem, this first multiplies this, and this one multiplies this, then the sum of that shall be getting OP. So from here now, my OP, or you can use the ratio theorem which is already here. So our OP will be 2 times the position vector of B, the position vector of B, then 3 times the position vector of A, then over the sum of these 2 ratios, 2 plus 3, and this will be 2 into OB is what? OB is 260, then plus 3 OA is 0, over 5. Now this will be this can be, we can remove this as 1 over 5 into, we can remove this as 1 over 5. So this will be into 4, 12, 0, plus 0, 3, then at 12. So remember, that's how we have that. Then we just simplify. So now our OP will be, this will be 4 over 5. It will be 4 over 5. This will be 4 over 5. Then this plus this, it will be 15 divided by 5. It will be 3. Then 0 plus 12 divided by 5. It will be 12 over 5. So now, this whole thing is, this is our position vector, which is 4 over 5, 3, then 12 over 5. But remember that they asked for a coordinate. A coordinate, we give it in a coordinate form, so 4 over 5, 3, 12 over 5. That's the answer. Now, if we come to externally, the condition is externally. Now, if it's externally, the ratios remember are, we have it now, AB, BRB. The ratios are 2 to 3. You are attached a negative to any. So, we may attach a negative to negative that. Or, what we say, you just start this is external division, you say, we have now A, B, then this is our line segment, then this is our P. That is dividing it externally. As simple as that. So, we said use the ratio theorem, if you use the ratio theorem always, so my number to me will be 2 to 3. But because it's external, you are attaching negative either on this or on this. So either this or 2 to negative 3. Any of those ones will work for you. But I'm doing this because I want, when I add them, I want a positive thing. That's why I'm taking this one. So using the ratio theorem still, now my OP will be, this, the first ratio is multiplying with the last coordinate. This is now negative 2 times OP, then plus 3 times OA over 3 plus negative 2, which will be, we substitute negative 2 into OA, which is 260, then plus OB, which is 3014, the whole over 1. When we add this, I want to be positive. So when we simplify this, will be now negative 4, negative 12, then 0, 0, 3, 12. And if we add, so that our OP is negative 4, negative 9, this would be 12. If we add like that. So now my coordinate P is external division to be negative 4, negative 9, and 12. So remember, that's how we do with external and internal division. Don't forget to subscribe to the channel. I wish you the best at sign out.